Now, let's take a look at question 39D from the 2016 exam. It reads, pentlandite, which is this compound here, is a common nickel sulfide ore that can be used to obtain materials required to produce sulfuric acid. This metal sulfide ore is combusted in air to form sulfur dioxide according to the following equation. This is the equation for that. This sulfur dioxide is then passed over 4 beds of vanadium pentoxide or platinum catalyst at 450 degrees to produce sulfur trioxide. This is the equation for the production of sulfur trioxide using the sulfur dioxide produced from the reaction of pentlandite with oxygen, combustion reaction there. Now, question D reads, use the collision theory to explain the effect of raising the total pressure on yield for 5 marks. Now, before we answer this question, let's take a look at what the examiner had to say and the syllabus point related to this question or points. It reads, this was considered a question which could discriminate the top candidates. Many candidates who responded referred to Le Chatelier's principle, despite the question explicitly stating that the collision theory be used to explain the effect of raising total pressure on the yield. A common mistake many candidates made was to refer to more collisions rather than referring to increased rate or frequency of collisions. Although this type of question has been asked frequently, candidates are still not comparing the forward and reverse reaction within the collision theory to explain the change in equilibrium position. I'll get back to this here and dissect this further, or just explain it a bit more based on some of the things I come across when I mark my students' work as well. I completely agree. I totally agree with what the examiner is saying here. I see this a lot as well, and I do point it out. But look, it keeps recurring, and I'm sure all the other teachers are doing the same, because teachers do read this document which I'm reading through here. The syllabus point where this question came from is right here at the top. It reads, collision theory can be used to explain and predict the effects of concentration, temperature, pressure, the presence of catalyst and surface area of reactants on the rate of chemical reactions. Right, so basically that's the syllabus point. So we can use the collision theory to explain. But Le Chatelier's principle is used just to predict the direction of equilibrium, the possible path the system will take when a change has been imposed on that system, which is what the examiner is saying here. Some students focused on the collision theory. Now, even when you are using the collision theory, you have to compare the frequency of collisions that are occurring on the reactants compared to the products. If the frequency of collisions is greater on the reactants than products, then yield is going to increase. And if frequency of collisions is greater on the products than reactants, it means there is more reactants forming, so yield is going to go down. Another thing in terms of this here, I'm sure the examiner has been really, I would say a little bit nicer here, because in my assessments at school, I would just say, explain the effect of raising the total pressure on yield, because I'm expecting students to be familiar with this syllabus point, because all my lessons you will see the syllabus point and I'll explain what the syllabus point means, and I'll keep reiterating it. I wouldn't have put this if I was the examiner. I would have just said explain, or if it says predict, it means you are using LCP. You can still use collision theory to predict. There is nothing wrong. The collision theory is more comprehensive. It covers both. But if you just want to quickly predict, the LCP or Le Chatelier's principle will do the job perfectly well for you. Now let's take a look at the answer to this question. If I increase pressure by decreasing volume, let's represent this graphically to see what's happening here. This is what's going to happen. I'm going to take some arbitrary concentrations of these substances here to say, okay, I've got sulfur trioxide here. There is no special reason for me doing this. It doesn't matter where I start with these, and then I've got sulfur dioxide at this level. Now, when I increase pressure, the sulfur dioxide will be affected more because it has got a higher partial pressure. So there's pressure on this side, this is time. So if I increase the pressure of the system, sulfur dioxide will be affected more, followed by oxygen, and then sulfur trioxide will be affected less. So we can see that the partial pressures of all the components within this system have increased. But then, if we look at the reactant side, we've got a total of 3 moles of gas here, and this one here we've got 2 moles of gas, which means the rate of consumption of products is going to be at a ratio of 3 compared to the formation of which is 2. So we are going to be consuming more reactants at a faster rate because of this ratio of 3 to 2. It doesn't mean that we've got more, but what this ratio tells us is each time you consume 3 moles of the reactants, you form 2 moles of that. So we're going to see a lot more collisions on this side as well, because if you look at our increase in partial pressure, it means the total partial pressure of reactants is much greater than the total partial pressure of products. Now, so as a result, we will see the partial pressures of products decreasing. This graph is not correct because it shouldn't go below, or it shouldn't be the same as what it was before. So because according to LCP or Le Chatelier's principle, the system will partially oppose this imposed change. So we will see the reactants decreasing in partial pressure, and our products will increase in partial pressure like that, which shows that yield is increasing. So that's what happens here. So let's put this in writing. In the exam, you are not meant to draw this, but because you are using this video literally to kill 2 birds with 1 stone, disclaimer, animal rights specialist, please don't come and find me. It's just a saying that I learned in school back in the day when we learned, are they called idioms? I can't even remember, in my English class. It's killing 2 birds with 1 stone. Yeah, we're doing 2 things at one go. You are revising, at the same time you are attempting this question to know the answer. So I have expanded this a little bit more. Now let's take a look at the answer here. How would we write it down? We would say increasing pressure. We have to acknowledge that increasing pressure increases the rates of collisions on both products and reactants. This is what I would have written if I was doing this exam, right? However, what's happening here? The frequency of collisions, the frequency of successful collisions will be greater on product side compared to reactants. This is because the ratio of moles of products to reactants is 3:2. As a result, more products will form increasing yield. Okay, you could have explained, I know I've tried to explain this in class using a rate time graph, but I find most of my students end up telling me, you know what, say, even though the rate time graph makes sense somehow, but the partial pressure time graph makes more sense. Now this label of time of this axis is now looking like it's part of what I've written. Let me just change that there. So yeah, that brings us to the end of this question. I shall see you when you attempt the next question.